Welcome to Beyond Protocols. My name's Mackay Rippey, and before you forget, I want you to visit us at mycotoxinmasterclass.com. That's mycotoxinmasterclass.com. If you're interested in helping your mold patients and clients get better, faster, and with fewer adverse reactions, this is for you. So go check it out, mycotoxinmasterclass.com.
Now. So let's remind ourselves a little bit about where some of the potential problems with peroxynitrite come in, because where we kind of left things were that peroxynitrite was identified and everyone got really excited about it. And then there was a group of researchers who went, oh, it's not actually a big deal. Never mind all of that. It's not really a big deal after all. But when we look at those breakdown products, what comes after peroxynitrite, that's where I believe you feel like things get really risky for the body.
Yes, that's exactly right. And so what's interesting in going through the research that I've been looking at over the past 3 years is there was all, like Emily said, all this excitement about peroxynitrite. They found it's strange to say because we talk about it being the 800-pound gorilla in the room and various other ideas that we make colorful language around. But it turns out peroxynitrite itself is not all that reactive. So compared to the hydroxyl radical, it's not super reactive, which sounds strange, which means it can travel a little bit before it oxidizes or oxidizes something it's close to, as opposed to the hydroxyl radical, which instantly oxidizes whatever's right next to it. Like the hydroxyl radical does not travel at all through a cell. Peroxynitrite can bounce around a little bit before it reacts. But what happens as it begins to react, it breaks down into various other things, including the hydroxyl radical. That's one of the breakdown products from it. And it also can combine with carbon dioxide. So these two individual radicals that form out of peroxynitrite. So peroxynitrite plus carbon dioxide equals the carbonate radical. So on one side you have the the hydroxyl radical, and the other side the carbonate radical. Peroxynitrite breakdown can also create hydrogen peroxide and superoxide again. So there's this, one of the reasons it's so tough to study is because it creates this whole kind of cloud, this stew of different radicals, and trying to sort out which one is doing what is really, really tough, if not impossible. So in America, they stopped studying peroxynitrite. Luckily, the rest of the world did pay attention to the experts in the US and they kept on studying it. And that research now is starting to cycle back, and we're starting to see US studies again, US funded studies pick up the flag for peroxynitrite again. So that's the real important thing to hear. It's my belief, and this is just a belief, that whenever you have inflammation, you have peroxynitrite. I don't think it's possible, and I could be wrong, but I don't think it's possible to have any type of serious inflammation without peroxynitrite being involved. And just as a reminder, peroxynitrite is the combination of nitric oxide and superoxide. So
So,
how was that, and what else?
so that was excellent. Now, can you refresh my memory on peroxynitrite, or maybe it is uncoupled NOS, and the decrease in ATP production? Because that was part of what really piqued my interest and what pushes us into our cell danger response conversation.
Yes, so that's a new study for me, and I haven't memorized it yet. I don't think I have it pulled up either, so I apologize for that. But two things happen. Nitric oxide in and of itself slows down phase one of the electron transport chain. It's part of when we get sick, when you get the flu. Why do you get tired? because your body's pumping out a ton of nitric oxide. Yes.
So that is a classic cell danger response type of presentation. So almost everybody has their cameras on. So did anybody go back and read over the metabolic features of the cell danger response? So I am going to highly, highly, highly recommend that you read this paper. And if you haven't read it lately, I'd go back and read it. By Robert Navio is the lead author on it. But this is our basic model for medicine 2.0 and for recognizing when and how we help break people out of chronic states of distress and disease. It's a pretty important piece of the puzzle. And so when we think about things like how the body moves into that first stage of cell danger response, or CDR1, one of the things that's characterized by it is a drop in ATP, which sends the body the signal to rest and heal. And if we go, oh, you're tired, let's push all these ATP supports at you, you might feel more energetic initially, but you are unlikely to actually get complete resolution. So understanding this model and some of these metabolic features of each of the stages of cell danger response is an important piece in figuring out why the body is doing what it's doing, and then how we help it complete this healing cycle to actually get full resolution. Because isn't that really our job? You know, if we, in the natural health and nutritional community or the naturopathic community are really committed to this idea that the body can heal itself, that the body has this inherent wisdom to heal, sometimes our interventions contradict that. We want to encourage them.